Okay, a question from the Polar Conics worksheet number 30. Okay, and the kids are being crazy right now because it's weekend, so that's okay. We're just gonna hope you understand. Okay, anyway, number 30, right? So there's one vertex, so we know it's gonna be parabola, and that vertex is at 1 negative pi over 2. So if I'm thinking about that vertex, that's telling me that it's going to be down here for that point. Okay, so there's my focus. There's my vertex. That means my directrix is down here. Okay, so looking at that one, I can see that my distance from the focus to the directrix is 2. Okay, and since it's a parabola, right, my eccentricity is 1. Okay, so I go to my equation. R equals 2 on top. Right, and then we're going to have 1 minus, and it's going to be minus because it's down below, and since this axis is in the y direction, right, it's sine theta. Okay, the eccentricity is in front, but the eccentricity is 1, so we don't have to worry about that. There's my equation for number 30. Okay, the second question that people had was number 39. Right, and so if I look at 39 here, the original problem says we're going to again write the polar form of the equation for the conic. We're going to have one focus is at 5, 0, and there's going to be a vertex at 4, 0, and another one at 4, pi. Okay, so let's see. So radius of 4, angle is 0, so we're going to have that as our vertex. Radius of 4, angle of pi, we're going to have that as our a second vertex there, and we're going to have one focus here. So if I know that that's a focus, then there's going to be a focus right here, okay, for myself, because the distance from each vertex to a focus. So it looks like I have a hyperbola here, right? That's what I'm expecting overall for this problem. Okay, since this one is since I'm looking at it, and my foci, there is neither focus is at the origin here, right? I can't use the traditional formula for myself on this one, so I'm gonna I have a couple different ways I can do this. Now, because this came in the problem set after we had done in 35 and 36, the polar form of the equation of the hyperbola being r squared equals an opposite of b squared over 1 minus e squared cosine squared theta. I can use that equation. Now, if I don't remember that equation, I could always put this into Cartesian form and then convert it over to polar form afterwards. But if we know that, that's great. That's going to help us to be successful and finish this problem. Okay, I know in this one that a is 4 and c is 5, so I can figure out b. All right, remember that b squared equals, in this case, c squared minus a squared because c is larger. So it's going to be 25 minus 16. So b is going to be 3. Okay, I was at 3, 4, 5. Okay, and now if we're trying to find eccentricity, that's c over a. So that's going to be let me make sure I have the right problem here. Yep, c over a. Right, so it's going to be 25 over 16 cosine squared. And then when I scaled both top and bottom by 16, so that I don't have any compound fractions, and that's where my final answer of r squared equals opposite of 144, 16 minus 25 cosine squared comes from. Oops, sorry, I went off the bottom of the paper there. Okay. Again, if you don't remember that formula, that's fine. There's no need to ever remember that formula. It's just one of those things that can be helpful. So if I was just going to go about doing this, and I didn't remember that formula, I would have said, okay, it was x squared over a squared minus y squared over b squared. Okay. So I'd have that, and then I would have replaced the x with r cosine squared, r cosine theta, and the y with r sine theta, and everything squared because that was squared. Okay. I would have multiplied everything by 144, and then factored out the r squared. That would have been 9 and 16 right there. And so 144 for myself. Okay. Divided both sides. Okay, and then just replace the sine or the cosine for ourselves. And this point, it'd be good to remember, hey, when we're writing these forms, we're always putting in times of cosine, so we replace this one with 1 minus cosine squared. Distribute out, combine like terms, and we get that same term, right? Eventually we get it to that form. So there is no need that you have to memorize that one. Okay? All right. Thanks for the questions. Keep them coming.